Here we have a pair of equations defining x and y in terms of the parameter t. The first thing I'm going to do is get a few points on the graph of this. And so I'm going to make a chart. I'm going to pick various t's. We'll put them last because that's how they're asking for it here. And we're going to find the x and the y that correspond with the various t's. Now, in looking at the equations, I have the square root of t. So I know I have a restriction. T has to be greater than or equal to 0. So when I pick my t's, I'll pick 0 and 1. And then I'm going to pick things that square root evenly. So 4 and 9. So it's easy to get these points. All right, so I'm going to put 0 in for t. Square root of 0 is 0. Putting 0 in for t in the y's equation, 0 plus 2 is 2. So I'm going to plot these on the graph as I go. And we'll do 1, 2, 3, 7, 8, 9, 10. And here we'll do... Okay, so 0 and 2 is a point on the graph. Now I will let t be 1. The square root of 1 is 1, and 1 plus 2 is 3. So the point 1 and 1, 2, 3 is on the graph. Now I will let t be 4. Square root of 4 is 2. 4 plus 2 is 6. So the point 2 and 1, 2, 3, 4, 5, 6 is on the graph. So right there. And then I'll let t be 9. The square root of 9 is 3, and 9 plus 2 is 11. So at 3, I'm up 11. So about right there. So this is what it's looking like, and we could have continued going. So I'm just going to make a couple arrows so you can see the direction of motion. That's kind of went a little wacky at the end. Let's fix that. Okay, so it's looking like that. Now let's go ahead and eliminate the parameter. So to eliminate the parameter, I look at these two equations I have and I solve one of them for the parameter t, and then I can plug it in the other one. I think I'm going to take this first one and square both sides. That would make t equal x squared, and then I am going to substitute x squared in for the t in the y's term. So putting x squared in there. Here is the equation with the parameter eliminated. And if I think about what that graph is, that is a parabola that is shifted up 2. So it would look something like this if I graph just this equation that I have right here. However, the thing I've got to remember is they were defined parametrically here to begin with, and so this restriction on t was important there, and that's why we only got this right half of the parabola. So if I didn't list a restriction for x on this particular one, it would be the whole parabola, and that wouldn't be right. So we only want the piece of the parabola from where x is greater than or equal to 0. So this is the restriction because the original graph and graph of what I got when I eliminated the parameter wouldn't match without that restriction. Now let's do something a little different so we can see about these restrictions again. Let's say instead of not listing anything, they told us that t was in between, and they could give it to us in an inequality or an interval in between 1 and 9. So when we went to get this graph, we would not have this one here because we would just do from 1 to 9. And so in modifying our graph, I'm going to take off that first point. And so the graph in this particular case, maybe I'll leave it in red so that you can see it clearly with the restriction. It's this piece of the parabola like this. And if that would have been the case, then what I would do to modify or put a restriction on when I've eliminated the parameter is then I would have x be, let's see, this would stop at 9. So I needed to, let's modify this graph a little more. It would need to actually stop when t was 9. So it would just be this little piece. And so if I was listing the restrictions so that when I eliminated the parameter I would end up getting the same graph, it's this y equals x squared plus 2, but we would only take it where the x was in between 1 and 3, because when the x is 3, that's when we'd get this endpoint of 9.